right, so for some particular reason we have decided to pull our friend in a wagon. We are pulling that wagon with a force of 45 newtons, and we're doing that at an angle, 35 degrees above the horizontal. We want to know how quickly are we accelerating in the x direction if we're given the mass of our friend in the wagon. So I've done a nice little sketch over here, but we're going to draw an actual real free body diagram for the situation. And as always, our object is a lovely square. All right, so that is my friend in the wagon. That particular object does have the force of weight acting down on it. It is being supported by the ground, which is the normal force. And then we also have the force of our pull that is 35 degrees above the horizontal. All right. So one thing to note here is that force of pull is not just in a single direction like we've been dealing with before. Now some of our pull is up and some of our pull is over across. So we do need to make sure that we're taking that into account as we do our math here. So now that we have our picture, we are ready to apply Newton's second law. Because we're looking for the acceleration in the x direction, we're going to start by applying the Newton's second law in the x direction. So when we do that, the sum of the forces in the x direction is equal to the mass of our object times the acceleration in the x direction. In this particular case, the only force acting in the x direction is just how much of our pull is in the x direction. I'm going to call that F pull x. Right? And you might be wondering, well, where does that come from? If I take just that one force and blow it up on its own, I have F pull here. I have the angle that it makes with the horizontal. That tells me that this is going to be my F pull x, and this is going to be my F pull y. This is a right triangle because we know x and y have to be perpendicular to each other. This F pull x is adjacent to my angle, so that tells me I need to be using cosine. So cosine of theta is equal to my adjacent over my hypotenuse. So F pull x over F pull. So when I rearrange this equation, I get the fact that F pull x is equal to F pull times cosine of theta. So now we have this. We can go ahead and substitute that into this equation. When we do that, we get the fact that our acceleration in the x direction is equal to F pull times cosine of theta divided by m. We have everything that we need to solve this problem. It is very important, however, that as you're doing this, you make sure your calculator is in degree mode. If your calculator is in radians, you will get the wrong answer. So, we're going to plug our numbers in. And we do see the fact that you are, your pull accelerates your friend at 32 meters per second squared. So that is our acceleration in the x direction. Right? So now that we have the first part, right, we're ready to find out what is the normal force on the wagon and the friend. When we start talking about the normal force on the wagon and the friend, we are now interested in the y direction. We're interested in what's going on up and down. So we're still going to use Newton's second law. But we get to simplify this particular equation because we don't have any up and down motion. We don't have any up and down movement. We are in equilibrium in the vertical. So we have no acceleration, so this term goes to 0. So now I have some of the forces in the y direction will equal 0. We have to now take into account, well, what are the actual forces we're adding? Up is positive, so we're going to look at our normal force, which is up, the y component of our pull is going to be up, and the force of our weight is going to be down. So when we take that, normal force plus F pull y minus force of weight is equal to 0. We're specifically interested in the normal force, so we're going to go ahead and rearrange that equation for the terms that we are interested in. So my normal force is equal to my force of weight minus my F pull y. Now we need to get some substitution in here. We are going to find F pull y the same way we found F pull x, but it's not my adjacent side anymore. It's going to be my opposite side. So so because it's my opposite side, I'm looking at sine of theta is equal to F pull y divided by F pull. So F pull y is equal to F pull sine theta. We're also going to keep in mind that Fw is equal to mg. So we are going to need that up here. So we're going to plug both of those in. And we can plug in our numbers. All right, and we do get 1,101 newtons or 1,100 newtons, all right, for sig fig. So that is the normal force supplied to the wagon and your friend as you pull him along. All right, hope that helps.